Hey everyone, welcome to The Explainer. I'm so thrilled to have you here today because honestly, we're going to look at something truly fascinating. When we think about the captain of a massive ship, we usually picture, well, a driver, right? Someone just standing there, steering a wheel, gazing out at the horizon. But under the international and inland navigation rules, which is exactly what we're focusing on today, that mariner is required to be something much more complex. They literally have to act as a highly analytical detective on the bridge. So today, we're investigating the incredibly strict, precise legal framework that governs exactly how mariners basically predict the future to stay alive. It's all about Rule 7, risk of collision.
So, picture this. In a boundless ocean, how do you know when a tiny speck on the horizon is a deadly threat? I mean, really put yourself there for a second. You're out on the open water. The visibility, it's constantly changing. Distances are entirely deceiving. There are no painted lanes, no stoplights, absolutely no traffic signs. A ship miles away might look completely stationary, but it could actually be hurtling towards you at 20 knots. So how do you legally and practically evaluate that threat before it's too late?
Which brings us to Section 1, the threat of collision, an overview of Rule 7.
Out of all the navigation rules, Rule 7 is basically the cornerstone of maritime safety. Out on the water, your primary objective, the mariner's primary directive really, is to progressively investigate and assess any risk of collision. You must use every single tool at your disposal to answer one absolutely critical question: are we going to crash? You can't just wait for the situation to resolve itself. You have to proactively hunt for the answer. So let's break down exactly how the law requires a captain to do that.
Okay, let's dive into this. Section 2, using all available means. This is Rule 7A.
Let's look at the foundational requirement that sets the baseline for everything a mariner does. And I want you to listen closely, because every single word here carries heavy legal weight. Every vessel shall use all available means appropriate to the prevailing circumstances and conditions to determine if risk of collision exists. Notice the language there. It doesn't say you should use or might use your tools. It says shall use. This is a strict, legally binding mandate, not just a suggestion. Whether it's your own eyesight, binoculars, listening for sound signals, or checking the radio, you cannot leave any stone unturned. If a tool is available and it makes sense for the weather or traffic conditions, you are legally required to use it to investigate.
And it goes even further. If there is any doubt, such risk shall be deemed to exist. This right here is the ultimate fail-safe of the sea. If you've used all your tools, you've looked through the binoculars, you've checked your instruments, and you are still scratching your head wondering, wait, are we going to hit that ship? Then, well, congratulations, the law just made the decision for you. You must legally operate under the assumption that a collision is imminent. You simply don't get to be optimistic on the ocean. Doubt equals danger. Plain and simple.
Moving on to Section 3, the radar reality check, which covers Rule 7B.
Now, while binoculars are great, we obviously have advanced technology today to help eliminate that doubt we just talked about. If radar is fitted and operational on your vessel, the rules demand it be used proactively. You can't just have the screen turned on and ignore it while you sip your coffee. Proper use actually means engaging in long-range scanning. You want to get an early warning way before a ship is anywhere near you. It also requires radar plotting, or at least an equivalent systematic observation of detected objects. Basically, you have to actively track where that blip is going over time. You are acting as that detective, gathering hard, mathematical evidence of the other vessel's trajectory.
That leads us to Section 4, the scanty information trap, under Rule 7C.
Now, what's really interesting about this is the clear contrast here. Remember, technology is only as good as the human using it. On the left side, we have your legal duty, gathering concrete data through systematic observation and long-range scanning. But on the right side, we have the real villain of our narrative, the fatal trap of relying on scanty information. This leads to assumptions, guessing, and working with incomplete data. The rules are actually hyper-aware of human psychology. It's incredibly tempting for a tired mariner to just glance at a radar screen for 2 seconds, see a blip, and confidently assume, oh, they'll pass safely behind us, no worries. But the rules expressly forbid this.
Scanty information is officially defined as inadequate or incomplete data. Rule 7C explicitly warns against making assumptions based on scanty information, especially scanty radar information. A single ping on a radar screen that tells you almost nothing about a ship's actual speed or intent. If you don't take the time to plot the target and gather a real sequence of data points, you are navigating on a guess, and out on the water, guessing gets people killed.
All right, let's look at Section 5, the compass bearing test, found in Rule 7D.
Let's move to and see how this builds into the physical world. How do we physically prove a collision is going to happen using the oldest, most reliable trick in the mariner's toolkit? It's a simple three-step process. First, you take the compass bearing of an approaching vessel. Second, you continually monitor that bearing over time. You don't just check it once and forget about it, you actively watch it. And third, if the bearing does not appreciably change, the rules dictate that a risk of collision is deemed to exist.
Let's simplify that into the absolute golden rule of navigation. Constant bearing equals collision course. Think about it like driving down the highway. If you look out your passenger window and see another car merging, and that car stays in the exact same spot on your windshield while getting bigger and bigger, yeah, you are going to hit each other. The pure geometry of the situation guarantees it. If the compass bearing to another ship is not shifting noticeably forward or backward as you move, it means your two paths are intersecting at the exact same moment in time. Boom.
But, of course, there are caveats. Section 6. Big ships and close calls. The exceptions to Rule 7D. As any good detective knows, there are always exceptions to the rule. So, the crucial point is that a collision risk may sometimes still exist even when you do see an appreciable bearing change. This happens particularly in three specific scenarios: when you're approaching a very large vessel, when you're approaching a tow, or when you're approaching a vessel at very close range. Why? Well, because a massive oil tanker or a tugboat pulling a barge that stretches for hundreds of yards isn't just a single tiny point on a map. You might see the bearing to the front of the ship changing, making you think you're safe, but you could still easily crash right into the middle or the back of it. The sheer physical size of the hazard completely overrides the simple geometry of the compass test.
So we've covered the mandate to use all available means, the strict requirements for proper radar use, the deadly trap of scanty information, and the geometry of the compass bearing test. It's a rigorous, frankly fascinating system designed entirely to save lives. But I want to leave you with a final thought to ponder. If navigating the seas requires such incredibly strict rules to combat human assumption and error, how often are we navigating our own daily lives, our decisions, and our relationships on scanty information? How often are we jumping to conclusions without actually plotting the data? It's a pretty powerful principle, both on the water and off. Thank you so much for joining me for this explainer, and remember, keep questioning the horizon.